Good morning everyone. In this lecture we are going to discuss about the Viterbi algorithm. This Viterbi algorithm is the one type of convolutional decoding. It is used to correct the error. The other name of the Viterbi algorithm is the maximum likelihood decoding. This Viterbi algorithm is fully based on the trellis structure. The trellis structure to be discussed in later lecture. This decoding has the two major parts. One is the metric value, another one is the survival path or active path. Metric value, it is as like a Hamming distance. What is the Hamming distance? The number of bits to be changed. And this value is added in a previous node metric value also. The final value is called this metric value. Next one is the survival path. In each node, after the second stage, two paths to be entering this node has two metric value. The path lower metric value is retained and the other path is discarded. This retained path is called as the survival path or active path. This retained path is called as the survival path or active path. Some steps to be followed in this Viterbi algorithm. The first step, the first stage and second stage as like a trellis. Finding the metric value for each node. This metric value to be found with help of received bits to be compare the coded bits. The initial node metric value becomes 0. Step 2. After the stage 2, each node receiving the two paths, each path having a single metric value. Therefore, after the second stage, each node have a two metric value. Step 3. Find the survival path with help of minimum metric value. Minimum metric path 1 will be retained, others are discarded. Step 4. Step 2 and step 3 are repeat until the receive bit sequence starts. Step 5. Finally, find the active path. This active path code where is the corrected code word and define the original message sequence from this decoding algorithm. Now we are going to see the one example. Now we are consider the message sequence 1 0 0 0 0 0. The code word in the transmission medium. In this medium, some error to be occurred due to several noises. In a receiver side, we are receiving the error code 0 1 1 0 1 1 1 0 0 0 0 0. Find and correct the error and get the original message sequence in a receiver side by using Viterbi algorithm, that means maximum likelihood decoding. Now we are going to start this problem. Stage 1. This acts like a trellis structure. Here there are two stages there. One is the present state, another one is the next state. One is the present state, another one is the next state. Here the receive sequence to be received one by one. The initial metric value, this initial metric value becomes 0. This initial metric value becomes 0. After that, the input sequence of the encoder becomes 0. It is mentioned as the solid line. The input becomes 1. It mentioned the dotted line. The input becomes 0. It mentioned the solid line. The input becomes 1. It mentioned the dotted line. Let's start. First, the present state A. The input becomes 0. It mentions the solid line. The next state is a. This time, the code word becomes 0, 0. Now we are going to calculate the metric value. This metric value to be found with help of Hamming distance. Now we are going to compare these two values, the 0, 1 and 0, 0. How many bits to be changed? Only one bit to be changed. Only the LSB to be changed. Therefore, the metric value becomes 1. 1 plus 0. This node metric value becomes 1. 1 plus 0, 1. Next, the same present state is A. The input becomes 0. The next state is B. This point, the code word becomes 1, 1. Here, now we are going to find the metric value. We are going to compare this 1, 1 to 0, 1. Only one bit to be changed. The value becomes 1. The Hamming distance becomes 1. The metric value becomes 1 plus 0, 1 plus 0, 1. We are writing this format. Next, stage 2. The stage 2, we are receiving the next receive sequence 1, 0. This stage 2, first, the input becomes 0, is mentioned the solid line. The code word becomes 0, 0. Now we are going to find the Hamming distance between the two values. Only one bit to be changed. The value becomes 1. The node metric value becomes 1 plus 1. Value becomes 2. Similarly, next the input becomes 1. It mentioned the dotted line. The code word becomes 1, 1. We are going to find the metric value. The Hamming distance between the two code words is 1. 1 plus 1. The value becomes 2. Next, this is state part. The present state is B. The input becomes 0. It goes to the 0, 0. C state. It goes to the C state. The code word becomes 1, 0. Now we are going to find the metric value for this node. The value becomes no change. The value becomes 0. The metric value becomes 1. Next, the present state is B. The input becomes 1. It mentioned the dotted line. The next state is D. The code word becomes 0, 1. Now we are going to compare these two code words. 1, 0, 0, 1. The two bits to be changed. The Hamming distance value becomes 2. The node metric value becomes 2 plus 1, 3. This is the second stage. Now we are moving to stage 3. This stage 3 is a special stage for this problem. In stage 3, each node to receiving the two path. This two path, we are having the two code word, and each node we have a two metric value. Okay, let us see. First, now we are receiving the third receive sequence 1, 1. First is that this step is followed by previous one. The code word becomes 0, 0. Compare this receive sequence to this code word. The two bits to be changed. The Hamming distance value becomes 2. The metric value becomes 2 plus the previous node value 2 is a 4. We are going to the similar way. Now, the present state is C. The present state is C. The input becomes 0. It mentioned the solid line. It mentioned the differential with help of green color. Okay. The code word becomes 1 1. Now we are going to compare this 1 1 to this 1 1. No change. The Hamming distance between becomes 0. The metric value, the lower metric value, the metric value for this 0 plus previous metric value is 1. This value becomes 1. Is mentioned as like that. The next present state is C. The metric value becomes the present state is Z. The input becomes 1. The next state is B. The code word becomes 0 0. Now we are going to find the Hamming distance 0 0 1 1. The 2 bit to be changed. The value becomes 2. The metric value becomes 2 plus 1 3. Similarly, the present state is D. The input becomes 0 is mentioned the solid line. The code word becomes 0 1. Now we are going to compare this value to this value. The 1 bit to be changed. The Hamming distance becomes 1. The node metric value becomes 1 plus 3 4. The present state is D. The input becomes 1 is mentioned the solid line. The code word becomes 1 0. Now we are going to find the Hamming distance 1 0 1 1. Only 1 bit to be changed. The Hamming distance is 1. The metric value becomes 1 plus 3 4. This is stage 3. Now we are going to find the stage 3 survival path. These are the metric value. Now we are going to see this node. In this node, we are going to find the survival path. Discard the maximum metric value. Only retain the minimum metric value. In this node, we have the two metric value. One is from A, one is from C. Which one to be low? A is to be low. Therefore, this A to be discarded. Similarly, node B. In this node, there are two metric value. One is from A, one is from C. The first value becomes 2, the second value becomes 3. The 3 is the maximum one, therefore this path to be discarded. Similarly, next the node C. Here there are two values, 3 and 4. The first value is the minimum value. This value is from B. The 4 is from D. This is the maximum value. Therefore, this path to be discarded. Finally, the D. There are two metric value. One is from B, one is from D. The D value becomes maximum. Therefore, this value to be discarded. This is the stage 3 survival path. The stage 3 survival path is used in this stage 4. This is stage 4. Next, stage 4, we are receiving the received code word is 1 0. Now we are going to find the similar steps to be repeating. The input becomes 0, is mentioned the solid line. The code word is 0 0. We are going to Hamming distance between the two code words 1 0 0 0. Only 1 bit to be changed. The Hamming distance is 1. The previous metric value becomes 1. 1 plus 1, the value becomes 2. Next, we are going to find similarly. This node metric value becomes 2. This node metric value becomes 2. This node metric value becomes 4. Similarly, next is B to A. The input becomes 0. Code word becomes 1, 1. Only one bit to be changed is mentioned in the green line because of each node receiving the 2 metric value, 2 path. Only one bit to be changed. The handling distance is 1. 1 plus 3, the value becomes 4. Similarly, C to B, the value becomes 4. D to C, the value becomes 5. D to D, the value becomes 3. Now, we are going to find the stage 4 survival path. The stage 4 survival path, now we are going to look at this node. First node, we have the 2 metric values 2 and 4. Here the 4 is the maximum one. This 4 metric value path is from C. This path to be discarded. Next node, 2 values 2, 4. The 4 is the highest value. Therefore, the maximum path value to be discarded. Similarly, this node we have a 2 values. One is a 2, another one is a 5. 5 is the maximum, therefore this value to be discarded. Here there are 2 values, one is a 4, another one is a 3. The 4 is the maximum, therefore this path to be discarded. This is the stage 4. Next, the stage 5, the stage 4 survival path to be used in the stage 5. The next stage 5 receiving code is 0, 0. Now we are going to find this the stage to be repeated. 0, 0, code word metric value becomes 2, 1, 1, the metric value becomes 4, 1, 0, the metric value becomes 3, 0, 1, the metric value becomes 3, the metric value becomes 4, this metric value becomes 2, this metric value becomes 4, this metric value becomes 4. Let's move to find this stage 5 survival path. Just look at this node's value. Here there are 2 values. One is a 2, another one is a 5. The 5 is the maximum. This metric value path is from C. That's for this value to be discarded. This node we have a 2 next this node have a 2 values. One is a 4, another one is a 3. The 4 is the maximum. Therefore this path to be discarded. Next this node have a 2 values. One is 3, another one is a 4. If the 4 is the maximum, therefore the 4 to be discarded. This node have a 2 values. One is 3, another one is a 4. 4 is the maximum, therefore this path to be discarded. Next we are moving to find the active path. Just look at this final node values. This node value, find which one is the minimum value. Here the 2 is the minimum value. Therefore the 2 is the first point. Next this point to be connected this node. This is the second one. Next this is the third one. And this is the fourth one. And this is the fifth one. Next this is the sixth one. This is the seventh one. This path is the active path from this minimum value to starting point. Next step, we are going to discard other path. Only look at this active path only. Okay. Next, retail part and its corrected code word. First, the first is the code word becomes 0 0. This to be corrected code word. Next, this value becomes moved to here. Next, this value to be moved to here, and next this value to be moved to here, and this value to be moved to here, and next this value to be moved to here. This is the corrected code word to be found in this receiver side by using this Viterbi algorithm. Here we are look at this, the two values, 2 bit to be error. One is the first bit 0 to 1, another one is the 7th bit 1 to 0. Next we are going to find the message sequence. First, this is the dotted line. The dotted line is mentioned the 1. Next, this is the solid line. This solid line mentioned is 0. Next is also a solid line. This solid line is mentioned the 0. Next is also a solid line. The solid line is mentioned the 0. Next is also a solid line. This solid line is mentioned the 0. Next is also a solid line. This solid line is mentioned the 0. Here the message sequence is 1 0 0 0 0 0. This is the original message sequence to be transmitted. This is the Viterbi algorithm and these examples. If you have any doubt, just refer these two books. One is the B.P. Latty, Modern Digital and Analog Communication System, Oxford University Press, the 4th edition. Next one is the Simon Hawkins books. If you have any doubt, please ask to me. Thank you.